Water is important because every single living thing, insects, plants, microorganisms, humans, we all need water to survive. And we're all using water every single day in all different parts of our lives. And because it's such an important resource, it's important that we figure out how we can best manage that resource and how we can make sure that water is here for many, many generations. One word that we hear a lot when we're thinking about aquatic ecology and water is the word watershed. What is a watershed? Well, the best way to understand what a watershed is if I cup my hands like this and rain falls from the sky, it'll collect in the palm of my hand. And that's kind of like what happens on land. Water hits a hill or it hits the side of a mountain and it goes downwards and it collects in the very lowest part. And the place where it collects could be a river, it could be a small pond, or even something as large as an ocean. The pathway that a drop of water takes here on the planet is called the water cycle. There is evaporation, so water going up into the sky. It goes to the clouds and condenses, that's condensation. When the clouds get really heavy, it rains back down as precipitation. As water hits the ground, it percolates going into the water table, or it rolls over the surface of the ground, and around and around and around the water goes. So it would seem that it's really simple, that circle, that water is always traveling and always moving and always available to us. But in reality, it's not that simple. A drop of water can end up in the ocean and stay there for 100 years or 1,000 years. It could get frozen in a glacier and stay there for millions and millions of years. So when we think about water and the water cycle in the context of large amounts of time, it gives us a better perspective of how we're using water. So the important part of watersheds is how the land affects and impacts the water that we are using. As water hits the ground, it takes whatever's on the surface along with it. We call this surface runoff. As the water runs off, it's either taken debris or it's taken chemicals or it's taken whatever we've added to the landscape. And that means that what we're doing on a daily basis has an impact on our waterways. If I'm walking outside and I have a bag of chips and I decide to eat my chips and then throw that bag on the ground, that's going to end up in my waterway. That type of pollution is called non-point source pollution because you can't point to just one person and say that cigarette butt belongs to John. The other type of pollution is point source pollution, and that's the type of pollution that you can point to the source that it's coming from. It could be an oil spill, or it could be a factory that is pumping their wastewater directly into a waterway. The question is, what is there more of? Is there more point source, or is there more non-point source pollution? The answer is, there is way more non-point source pollution in the world than any other kind. So you have a direct impact on how clean your water is. Stream water is a way that scientists can classify and order bodies of water that are moving bodies of water. So a first order stream is a stream that is coming directly out of the ground. So it tends to be small, maybe not as fast moving. And as you go up the orders, the streams are wider, they are faster, they are deeper, and that helps us to classify them. And when we classify streams by their order, we can make predictions about what kinds of creatures are going to live there and what type of vegetation is going to be there as well. When a scientist is studying a body of water, they're taking in all of the clues that are around them. They're looking at the vegetation, they're looking at the land, and they're also looking at the water itself. They are looking at two different factors, really. They're looking at the abiotic factors and the biotic factors. Abiotic means non-living, and biotic means living. Some of the abiotic things that scientists are looking for are the pH or the alkalinity. They're also looking for how much dissolved oxygen is in the water, the temperature, carbon dioxide, all of those things are abiotic factors that really affect the health of the water and determine the creatures that are going to live there. One of the chemical sampling tests is a pH test, and that gives us an indication of how acidic or how alkaline the water is. For the most part, bodies of water need to be between 6 and 9 to have the most abundant amount of creatures and plants living there.
7. So that means it has perfect pH balance.
Another chemical test is the dissolved oxygen test. We want to know how much oxygen is in a body of water because most creatures need oxygen to survive. And that's going to give us an indication of how healthy our ecosystem is. You can also tell how healthy a stream is just by looking at the different kinds of living creatures that are there. This is the biotic factor. You can tell if a stream is healthy by looking at the classes of organisms.
That's what
I'm saying. It's like a little, like really little.
Some organisms are very tolerant to pollution, so if I go to a stream and I see a ton of mosquito larvae, which are very tolerant to pollution, I'm going to know intuitively that this particular body of water is probably not so healthy or polluted. But if I see a lot of organisms that are really sensitive to pollution and they're thriving, I'm going to know that this particular body of water is healthy. My favorite part of testing water is collecting living creatures, because what's more fascinating than looking at a live organism getting its needs met in the water? But in order to understand what these creatures are, I have to figure out what they are. So oftentimes we use something called a dichotomous key. It's kind of like a map that tells us what these things are that we are looking at.
You can't even tell if it got eyes. You can't really tell by the face of how it looks.
But you can't see that.
Oh, it's a true fly.
I told you.
And I can key out, does my organism have antenna? Yes or no. Move on to the next question. Does my organism have appendages, things sticking out of the back of it? Yes or no. And so on and so forth, until I narrow down what creature it is that I'm looking at. It's very easy for us to picture water in places like a pond or places like an ocean or places like a lake. But there's water everywhere. There's water right below our feet here in the ground. And one of the places where there's a lot of water below the ground is a wetland. There are all different kinds of wetlands. Wetlands are very important because wetlands are able to both filter water and also hold water and release it into the environment slowly, which is ultimately what we want soil on the land to do. Wetlands provide a buffer, so when it rains and that surface runoff is running off of the surface of the land, it will hit a wetland and the wetland soil will be able to hold that water there in place so that it doesn't continue rushing into the next area. Wetlands can filter out lots of pollutants because the soil itself binds those pollutants. And as the water is percolating through and moving through a wetland and going into the water table, it's being cleaned and filtered by the plants and the soil that are there. Don't forget to go outside and take a walk and really look at what's going on all around you. Being able to really come outside and engage with nature is something that's very special and eye-opening. It'll make it so much more real for you.